Good morning, ladies and gentlemen. So today we have one interesting question under statistics, but specifically hypothesis testing. So the question that we have reads to say, consider the following hypothesis test. So we have the null hypothesis to be less than or equal to 25. Then we have the alternative hypothesis to be greater than 25. So the question that we have reads to say, a sample of 40 provided, a sample mean of 26.4. The population standard deviation is 6. The first question we have is compute the value of the test statistic. The second question we have is what is the p-value? The p-value is just the same as the probability value. So for you to basically find the probability value, you need to check the n value. The n value in this case is a sample of 40. You check whether is the n size greater than or less than 30. If it is greater than 30, we use what is referred to as normal distribution. But if it is less than 30, then you use what is referred to as the t distribution. We will put into consideration all measures of the population. Then the C question reads, say, at alpha is equal to 0.01, what is your conclusion? So for you to come up with the conclusion at alpha, you need to understand what is referred to as, if the p-value is less than the alpha, what do you do? Do you reject or accept? Then if the p-value is greater than the alpha, do you accept or reject? You need to know that. Then where do you get the comparison of the p-value and the alpha? The p-value is the one that was previously calculated. Then what is the rejection rule using the critical value, and what is your conclusion? So for you to basically find the critical value and come up with a conclusion, you need to understand what is referred to as the level of confidence. So let us put into consideration how basically do you calculate the test statistic. So let us compute the test statistic together. So for you to basically compute the test statistics, now we need to understand that we need to calculate what is referred to as the standard error, where the standard error is equal to standard deviation divided by the n square of the population. So we know for sure that the standard deviation we were given in the question is 6, and the n size we were given is 40. Then we just go directly, we punch 6 divided by open bracket the root of 40. So we get our answer to be that, which is 0.9487, putting everything in 4 decimal places. So that's what we have. So immediately you calculate the standard error. We use now the standard error to replace on the standard deviation in the z-score formula, which is equal to mean of the sample minus mean of the population divided by the standard error, which you are from previously calculating. So in this case, the mean of the population you were given, the mean of the sample you were given is 26.4, and the mean of the population you were given is 25. Then you divide this with 0.9487. Then from here you subtract 26.4 minus 25 divided by 0.9487. You get the value to be 1.48. So this is the value for the z-score that we basically have. Then, so immediately you compute this value. This is the test statistic value which they wanted. Then the second question wanted you to calculate the p-value. So for you to basically calculate the p-value, you need to understand, before you calculate the p-value, what tail test is this question basically looking at. So for you to basically look at the tail test, you need to look at what is referred to as the alternative hypothesis. So the alternative hypothesis here, which is H1, signified that we have the population mean to be greater than 25. So if it is greater than, which means it is starting this side, it's starting here going the other side. So which means you are dealing with greater with greater values. So meaning this is a right tail test. So if it is a right tail test and you know that if you are dealing with the normal distribution table, basically there on the normal distribution table, you're only dealing with values which are less. So in this case, you need to subtract the value that you will get from 1. Then immediately you come up with that conclusive definition. Why are we using the normal distribution table? We are using the normal distribution table because n is greater than or equal to what? 30. This is the general rule for you to know which table you are basically looking at. So we will go look for 1.48 on the normal distribution table, and this is what we do. So you go to the positive normal distribution table. So it is 1.48. So we know for sure that 1 is basically starting from here and 1.4 is here. So 1.48, you come all the way to here. So this is the probability distribution that you basically have. So you get this value, you write it down, which is 0.9306. So that is the probability distribution that you calculate when you are given 1.48, the one which you previously calculated in the previous question. So remember why we are subtracting. We are subtracting because this is simply the right tail test. And from here, we just subtract the 2 and you get the value to be 0.0694. So this is the p-value that you basically have. Then the second question which we have here is C is at alpha, which is 0.01. What is your conclusion? Remember, for you to come up with your conclusion, we need to understand if the p-value is less than the alpha, do not accept. If the p-value is less than the alpha, do not accept. But if the p-value is greater than the alpha, please accept. So what we are trying to put across here is this is the alpha and this is the p-value. So get the p-value, the one you previously calculated. Then you put the alpha here. Then you check under human reasoning. You ask yourself, between the two, which one is big? This one is big. So if this one is big, then we need to accept. So there we accept. So this is how basically you calculate such. Then the last question, which is D, what is the rejection rule using the critical value, and what is your conclusion? So for you now to use the critical value to be the rejection rule, we need to draw our table like, which is a graph like. We will even look at more of this when we are looking at what is referred to as the chi-square distribution. So one thing that you need to understand, remember the alternative hypothesis said that this was a right tail test. So it was a right tail test. So we are only allowed to shade on the right tail test, and this is where the critical value will be. Then immediately now we will deal with that. So for you now to basically find the critical value, remember this here is the do not reject region, and this one is the reject region. This one is the rejected region. So how do you basically now find the critical value in this case C? You need always to get the confidence level. The confidence level is the alpha. So the alpha is known as the alpha. For you to get the confidence level is equal to 1 minus alpha. So you will say 1 minus 0.01, you get the answer to be 0.99. So immediately you get this 0.99. What do you do with this 0.99? So with the 0.99, you take it to the normal distribution table. So this in this case is the probability. So you need to look for 0.99 on all those numbers you are always given on the normal distribution table. You look at which value is closer to 0.99 and use the reverse format of the normal distribution. So immediately we are using the reverse format. This is what we basically do here now. So let us use the reverse format of the normal distribution table so that you see what I'm trying to put across. Remember, we want to calculate the value of the critical variable there. So on all these numbers, your main deal is to look for 0.99. So you understand that 0.99 is starting from somewhere here. So this is where 0.99 was starting from. But if you understand again, this is the perfect 0.99 there is. Even this one, yes, is 0.99. Even this one, but not this one, because when you round off, it will be a little bit ambiguous. So if you want, you can add the reverse format of these numbers. So what we can basically do here is we can choose this to be the 0.99, which is perfect because it is closer to 0.99. Then the reverse format is stating as you get, remember we have chosen this one, so you will get 2.30123. So the critical value is 2.33. So the critical value is 2.33. So this is how basically you calculate the critical value by using what is referred to as the reverse format of the normal distribution table. So now that we have calculated the critical value, which is 2.33, how do we basically now use this critical value to reject or do not reject? Remember, there was an answer that we had found at first, which is 1.48. So you check, where can 1.48 fall into? Can it fall into this region, or can it fall into this region here? So when you check, 1.48 is lesser than this number. And if you, let's assume this was a number line and we have our 0 here. So you will basically understand that 1.48 is in this region. So remember, the question that we had was to using the critical value as the rejection rule. What is your conclusion? Our conclusion is we should not reject the value that has been calculated. The reason being is because it is falling in the do not reject region. So this is how basically you approach such kind of questions, by using either the critical value or the alpha. So remember, under the alpha, we said we are accepting. And here we are also accepting. Very funny, huh? Your host, Golden Zone.